We often hear the phrase called data do not tell lies. There are so many books written with the same line called data do not tell lies, right? Exactly the same point I'm going to prove here. And now we're going to see this is the data is coming from Minitab. I'm really inspired with this. So now we're going to predict, we have a data until 2000. This data is about Olympic data, winning times the men 1500-meter run in the Olympic all the way from 1989 to 2000. How much seconds they have taken on the competitions during the competition. So now what we are gonna do is that we are going to predict 2024 and then try to see whether it's matching or not. Okay, let's start. So I have a data. One is year data, year wise. Another array I have time. All I'm gonna do is that I'm gonna select this chart and go to insert, and then simply I can give recommended chart. Recommended one of the chart I have chosen is that line chart or also scattered one. So just give here, just get rid of the line and all that. But we know that the value start from 200 seconds. So I'm gonna give 200 here. This is done. Now it has come nicely the chart, and all I can do is that I can just make it bold. Okay, I select the corner and then second control B. Automatically everything is became bold. So we don't need this time also. Maybe we can. Okay, this is one. And once it is done, what we can do, we can go to a layout chart. In the layout chart, we can find out whether the linear regressions, right? Again, once again, what I'm doing it, I'm just removing this one, and you can see here. And then what I'm doing is that I'll keep this line here. So there is a real linear relationship you can see here. I'm just clicking this dot. I'm going to this one, and default is a linear one, right? So linear relation says that the year and this is year and the time taken on 1500 run. So it is been linearly progressions. That means it is as the year go by, the time has taken less. That's what it signifies, right? This strong R square shows zero point 0.8. That means a strong correlation between these two variable, right? And now what we're going to do is that we're going to pick this equation and then substitute. So we know that our y is the year, right? And then how much time it has taken, right? X. So what I'm going to do is that I will just keep this year. I'll just copy this value, keep it here. Almost the same equation it has been given by this is given by Minitab, and now this is the example it is coming from Excel, right? So this value y equal to mx plus c. So m is a slope line x. So x, let's say we assume that it is 2024, right? This is the current year. And if you give here, I'm doing it, I'm just keeping it equal to, so 198, right? So 198 one. So again, if you divide this by 60, because this is seconds, right? So we need in minutes, right? So that means 3 minute, almost this one, 3 minute, 3 seconds, right? Exactly the same thing we got it. 3 minute, 3 second, exactly the same thing, right? We have the data until 2000. We predicted for 2024, right? What we did, we simply substituted the slope line y equal to mx m into x plus c. C is a constant. So we just substituted and we got this value, exactly the perfect value we got it. It shows that, so 198 seconds. In other word, it is 3.3 minutes. So exactly ditto, we got the right answer. And now we can also do further analysis also as well. For example, let's say if you wanted to see any other one, for example, let's say this is already a strong correlation, but just in case if you wanted to see polynomial behavior, you can see it is even more strong. There is curvature is getting formed. You can see here. So 89 is, but the equation is very complicated. So let's say I will just keep it with the linear because already is a strong correlation. We need to not to worry. So the bottom line is that data do not tell lies, right? So this is the exactly what we are going to prove in this video. I know, I hope you have enjoyed this video. Please do like, share, subscribe my channel. You have wonderful day ahead.